So so this is right. Okay, so I think we can start. I had to cut off this. I'll just start explaining again. You guys have not missed anything serious, right? So I'll just start explaining again. Okay, cool. Right, so this is the sliding. So we were talking about the sliding window approach, and we were talking about when you learn a new technique, it's very important that you understand the reason behind you learning that technique, because you cannot just go on and you don't even know why you're using that technique, right? That would be disastrous. So before, right, so the question is simple, right? The question is actually simple. You just need to calculate the maximum sum in a subarray having a size of k, that is 4. Okay, so the very simple thing that obviously comes to your mind must be, we can just start at this particular index, the first index. We can start and go till this point. We can calculate the sum, and that would be something. We can calculate this starting from the second index, from the third index, and so on till we have covered all the indices. The last one to be covered will be this one. Now we will start the value of I, the first for loop. Okay, the brute force. This is the brute force approach actually, right? So the brute force approach would be to go from I to n minus k plus one. The reason being, we cannot start the index from here because there are just three elements. The fourth element is not present over here, so we'll have to go from 0 to n minus k plus 1. And the second for loop would be going, so the current sum will be 0, right? Then we'll go from j, we'll have a new other index j, which will go from j is equal to 0 to k, right? So we'll have j is equal to 0 till the value of k, and we'll add all the values inside this subarray. The current sum will be current sum plus array of I plus j, array of I plus j. Okay, fine. Array of I plus j, cool. I is 0, so j is 0 plus 1 plus 2 plus 3. Okay, right. And then the maximum sum is just simply the sum maximum of the current sum and the maximum sum that we have received, and then we just return the same. And then we just simply return the maximum sum. Now this is an approach which will work in big O of n square, right? So a brute force approach, okay, that is what you would expect from this approach. Big O works in big O of n squared, okay, right? Now the next approach that would be working. Now the next approach. So that is why we need an optimized approach, right? That is why we need a better solution to this problem, and that would be to actually use a sliding window technique. Oh my god. All right, never mind. Right. So should I code this out? Like it's already coded. I mean, right? We've pretty much understood how this works, right? So we're just simply using a nested for loop. And if you've not understood why we're doing array of I plus j, I can just give you a dry run. So which is, for example, this is, I'll just take this as 0, 1, 2, 3. I'll just show you the first subarray. So when the value of I is, let's say 1, okay, which means it is at this point, the value of j will go from 0 till all the way till j is less than 4, okay? And right now, so the value of I is 1, and we're actually saying array of I plus j, which is array of 1 plus array of 1 plus 1, which is array of 2. Then you have array of 1 plus 3, which is array of, I'm sorry, 1 plus 2, which is 3, and then array of This will go till 3. So this will be 3 plus 1, which is array of 4, right? So it basically goes and traverses 4 indices and adds them all up. Okay. And then we can calculate the sum. Whatever the sum is, we can compare it with the maximum sum value, and then we can get the maximum sum in the subarray. This is a big of n squared approach, right? Now, this is the reason we talk about the sliding window approach, because what the sliding window approach does is it basically calculates this whole thing for us. Okay, so okay, I'll just use this. Now, this is a very nice, what you can say, an approach. Okay, it's just so nice, and it's really efficient. And if you think about it, it's quite smart. Okay, it's smart that they've made this. So what was the size value was k was 4. We can create a sub array of 4 here, right? So this is the sub array. Okay, 1 2 3 4. Okay, and this is there, right? So now what you can see is what the sliding window actually does is it will first calculate. So we declare a window of size k, okay, a fixed window of size k. You calculate the sum from in the first window, which is 1 plus 4 5 plus 2 7 and 10 17, right? I'll show you a test run. So initially the sum is going to be 17. All right, initially the sum is 17. What we're going to do now is we're going to move this window right here. Instead of calculating all the sum of all the indices all over again, we'll add 23 to it and we'll subtract 1 from it. Why? That is because if you think about it, we're just moving this window like this, right? The only elements changing are 1 and 23, right? The rest of the elements, which is 4 2 and 10, they remain in the window itself. So 1 leaves and 23 enters the window. So we, for that reason, we add 23 and we subtract 1, and you can check that this will be 17 and 23. So this is 30 and 30. 1 minus 1 is 30, right? So and if you try to calculate this alone, this will obviously be the same, which is 10 and 23, 33 and 6 is, wait a minute, I made some mistake, right? So I'm sorry, this is my bad. This is 23 and 7 is 30. 30 and 10 is 40, minus 1 is 39. So that is again 33 and 6 is 39, right? The same thing will happen again when you try to move this to the right. So that will be again, you'll add 3 to it. You'll subtract 4 from it this time. Okay, because 4 is leaving the window. So we'll subtract 4 from it this time. And that will actually be equal to, this is just minus 1 simply, so we can write it as 38, and you can see this is 23 and 23 and 3 is 26, and 36 and 38, right? So that is how simply the sliding window works. Okay, if you look at the code, I think I would like to code this up for myself. Time complexity is big of k times of n. I told you the big of time complexity is k times of n, not big of n squared. Sliding window, okay, I like to brute force sliding window time complexity. The brute force takes has a time complexity of big of n squared that involves necessary follows. It's here as well. That is nice. I think it's the same one, same tutorial. It's length of the longest substring character. Fine. Let's look at the okay. So right, applying the sliding window technique. We compute the sum of the first k elements out of n terms using a linear loop. Store the sum in window sum. Then we will traverse linearly over the array till it reaches the end and simultaneously keep track of the maximum sum. To get the current sum of a block of k elements, just subtract the first element from the previous block and add the last element of the current block. Right. So I've already explained to you how this works, and to code it up, you can simply see this. Now here we are just creating an array. We're just having the size k, just declaring the size of n, the value size of array which is n, then calling the max function. What does this do is basically if the value of n is less than equal to k, it is invalid. Probably this case will not be given to you. We can just leave this out. We'll start from where it max is zero. The maximum is initially zero. For int I0 is I is less than k plus plus max sum plus is equal to array of I. So we compute the sum of the first window. The window sum is equal to maximum of sum. The window sum is max sum. And then the window sum is equal to max. So compute sums of remaining windows by removing first elements. So the window sum is equal to maximum. The window sum, right. So basically we say that the window sum initially is equal to the maximum sum, which is this sum only, right? It's the current sum, you can say initial. It's not the maximum sum actually, but it's like the current sum. But we have to give the maximum sum some value, right? It needs to be the max sum variable needs to be given some value, and that's why we just assign it to value of the first window. And then we say window sum plus is equal to array I plus array of minus of, we add the value of array of I and we subtract array of I minus k, right? So we add array of I. Okay, I'll show it to you. So basically when we move this like this, all right, we add the value of I, which is, oh my god, sorry, we add the value of I and we subtract I minus k. Okay, so window sum plus is equal to array of I. So I is equal to k. We start from, obviously we're starting from this point. Okay, the value of I starts from k, not from 1 to, it starts from k. We add this value, which is 23, and we subtract the value of I minus k. If this is 0, 1, 2, 3, and this is 4, let's say. So 4 minus k is 4, and we subtract this point. Getting the point? So we add I and we subtract I minus k, which is the last element. Okay, so we'll code this up right now. So I'll just create a vector. Let's create a vector of size of n. I'll need to define n. So I'll say integer n, scene n. Then I can say for auto and percent a scene x. What we're going to do is we're going to calculate the initial sum value, max sum. Okay. Or I think uh, just to not get confused, I could put this as int min. Does not matter, but I can just, I know I'm creating an extra variable, but just for the, okay, that's not required. Right? So I'll just give it 0. Now I'll say that now we will say that the value of for in I0, I is less than, we'll need the value of k as well, right? So k, this is k, a plus plus maximum plus is equal to array of I. This is a maximum sum. So then we will say, okay, then we'll define the window sum as the maximum sum. Initial window sum. So the initial window sum will have to, because we'll be calculating some window sum that will be defined as the maximum sum initially. And then we'll say for integer I0, I is k, remember that? I is less than n, I plus plus. Not n again, it will be I minus of I, it will be, okay, this is, okay. I was confusing it with the brute force, sorry, my bad. So we will go till n only because we need to subtract, we need to add the last element, which is n minus 1. So we will cover the n minus 1th element as well. So we'll just simply say that window sum plus is equal to array of I minus array of I minus k. And then the maximum sum is equal to maximum of maximum sum and the sum and the window sum. And then you can simply say maximum sum, right? So we have this, we have this. Okay, so if we try to run this, I can copy and input from here. So we can say, I'll just copy this. So I'll say initially the value of n is equal to, let me see, 3, 3, 6, and 3, 9. The value of n is 9, k is 4, and then I'll enter these values 1, 4, 2, 10, 1, 4, 2, 10, 2, 3, 1, 0, 2, 3, 1, 0, and 20. And the answer is 24, right? So nice. Okay. So this is the sliding window technique. Okay. Pretty nice. The sliding window technique. All right. Okay. Right. I could create this as a function. If I was to say, I could use this as a function. So I would, in that case, I would say calculate. I would just say calculate max sum, max sub array sum. Okay, I think it would be better called max sub sum, which is maximum sub array sum vector integer ampersand a and integer k. I mean, I can pretty much calculate that there. So integer n is equal to a dot size. And I can simply say nk is c9k vector integer a, and I will need this maximum sum, and then I can just copy paste this here. I can say this, and then I can set it on the value of maximum sum, right? I can call this maximum SS, which is maximum sub sum, and I just pass the value of A and K, right? Which is obviously the same thing all over again. I just copy this. Maybe we can try a different input this time. 1, 4, 2, 3, 23. Was it this one? No, this is different. So this time I should get 39. Let's see. So This is 3, 3, 6, 3, 9 elements. Value of case 4 again, 1, 4, 2, 10, 1, 4, 2, 10, 23, 3, 23, 3, 1, 0, 1, 0, and then 20. Value set in absolutely nice. Okay. I think we could name this sliding window sum. Sliding window sum. Sliding sliding window sum, right? Great. Sliding. All right. So this is how the sliding window sum technique works actually, right? The time complexity for this is simply we go of n because we're just iterating through the array and we're subtracting and adding. So it's just simply we go of n. Now let's find some problems to solve. Another another technique it talks about the smallest subarray with sum greater than a given value. Smallest subarray with sum greater than a given value. Right? I think we can try it on practice, right? It seems like a good problem to me. What if I wanted a problem? What if I wanted to solve this as well, right? Okay, this is not available as something that I can solve sliding window. I wonder if I can have anything on hack time. Sliding window actor rank. This might be different from what I was expecting. Right. Smallest subarray with sum greater than a given value. Okay. I mean, it sounds interesting. Let me see what is the problem. The problem is given a number x and an so the problem says given a number x and an array of integer ARR, find the smallest subarray. Okay. With sum greater than a given value. If such a subarray does not exist, return zero in that case. For example, if you have value of 51, you have this subarray. If there exists, what is the smallest subarray which has a sum greater than 51? Okay, smallest subarray with sum greater than a given value. Let us try to think about this problem, right? Before we look at the approach, before we look at how this problem is solved, let us try to think about it. And let us actually try to think about it because it seems like a pretty good problem to use your brain on how to use the sliding window approach. La 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 la. I want it that way. Okay, right. So we have 1, 4, 45, 60, and 19. The value of x is given to us as 51. Now, what the question wants us to do is to basically calculate the minimum subarray that is possible, which gives us a value greater than x. Okay, with greater than this value right here. So that is obviously can be seen quite easily. The minimum value you can take is 2, even if so it does not matter if you take this or this, the minimum value possible is minimum subarray value possible is 2. How can we solve this problem using the sliding window technique, right? How can we solve this problem using the sliding window technique? Problem, that's the question. Okay, so okay, let's just remove this. Okay, so if we think about it, the if we have a window now, in this case the size varies actually, right? The size, minimum size varies. In this case we don't have a sliding window that has a fixed value, right? If we move from okay, I don't know how to solve this problem, but I'll try to. Yeah, I'll try to solve this problem. I'll try to take 5 to 10 minutes to think about it, how I can go about this, because I know the sliding window technique. Okay, let's first talk about the brute force approach. Let us talk about the brute force, which is the nested for loop approach again. So what we can do is we can start from one. And now it's going to be very tedious because you'll have to start from one, go till 4, calculate the sum, go till 45, calculate the sum, go till 6, calculate the sum, go till 0, go till 19, and then calculate all the sums. So in this case, it would be a big O of n squared kind of problem, right? Then you'll have to start from 4 and 45, 4 and 6, 4 and 0, 4 and 19, 45 and 6, 45 and 0, 45 and 19, 6 and 0, 6 and 19. And you'll have to see when you get the minimum value. So it would be a big O of n squared, okay? The brute force approach would be big O of n squared. Let us think about the optimal approach. We can start from 1. We calculate 1 and 4. We calculate 1, 4, 45. Okay, so 1 and 4 is 5, 45 and 5 is 50. We get a value which is, okay, so wait a minute, we need 45 and 4 is 49. Okay, I'm sorry I said this. The only possible value, the only possible subarray is actually this one right here. This does not qualify. This is 49, right? I'm sorry. This 45 and 6 is 51. It says greater than the given value. But yeah, that would be 3. Again, I'm sorry. I didn't see it, guys. It's 3, not 2. It would be 3 because you have to take minimum 4, 45, and 6. So I was saying 1, 4 I calculate, which is 5 and 45 is 45, right? So you start at here, you calculate 1 and 4 is 45. I mean, 1 and 4 is 5. 45 and 5 is 50. And then 50 and 6, it's still less. So we move on. 50 and 6 is 56. Now, what we know is that 56 is actually greater than 51, right? We know 56 is greater than 51, which means there is some value that can be removed from the array, subarray, in order to make the value less than. Is it possible to make a value which is less than? Now, why are we trying to remove the element? Because we want the minimum subarray, right? What we do is from the left end, this is the right end, this is the left end. From the left end, we try subtracting an element. What if we try to remove 1? When we have, and then we're left with this subarray, which actually gives me the value, which is 45 and 6, 51 and 4 is 55. We try to subtract again because 55 is still greater than 51. We try to subtract again, and 55 minus 4 is 51. And 51 is equal to 51, which does not qualify our constraints. And that is why we don't do that. And the minimum subarray for now, okay, this is not the final answer. Remember that. For now, the minimum answer is 3. So we store the value 3 as our answer for now. And what do we do now? Since we have 4, right? Okay, we got that, right? Okay, now what we can do is we can probably start with this index. We have it, right? We have the values like this. We have the subarray like this. This pointer is actually over here, right? And this pointer over here. We can move this pointer. Now what we can do is we can again see if this, what does this give us? So it just simply gives us 55 again. There's no change. There is no change. So we cannot move this. We try to move this 19, which gives us a value. We try to subtract. We try subtracting. We try subtracting. We do not get a value 51, greater than 51, and the answer is actually 3. This is a very good, interesting problem. Let's try to code this up. Let's try to see where it goes. right? So we start with right. So we start with what we can do is we can firstly let's define the size of the vector, which is simply the array dot size. Okay. Now what I want to do is I want to create I want to have two pointers. Okay, I want to have now remember it's not a pointer approach. Okay, it's not a two pointers approach because we have a sliding window kind of thing. And what we will be doing is in order to calculate the values when so I'll have a window like this, right? I have a window like this initially. Okay, I'll explain this to you actually. 1445. If I can copy this again. Wait a minute. So right. So this is the window initially. Okay. What's going to happen is I'm going to increase this window right like this. I'm going to add 4 to this, add 45, add 6, 0, right? And when I reach 40, when I reach 6, I will see the sum is 51. And then I'm going to decrease it from this point in order to, I'm going to subtract 1 from it in order to see if I can get a smaller size window. I'll try to subtract this, which will not work. So I'll keep it like this. Then I'll increase this. I'll see this does not work. I'll see this. I'll try to subtract this. I'll see it does not work. I keep it like this. The minimum answer comes out to be 3, right? So that's the approach that I'm going to take here. And I'm going to take this approach and okay. So initially I can say integer window size. Okay. For integer I is equal to 0, I is less than n I plus plus. I can define an integer. I want to store the minimum value, right? So integer minimum size will say is equal to 1. There cannot be a size. If it is not possible, we return 0. Okay, so I'll just keep this as 1. I'll keep it as max initially because right. So I'll say integer current sum is equal to plus is equal to a of I. Okay. Now this a of I is whatever it is, right? So it will add this value of 1 initially, right? So it will add this value of 1 initially. We'll just declare it right here. Right. Okay. Now what will happen is when I declare this, it will say, okay, so the value is 1. I'll check if the value of current sum becomes greater than the value of x. Okay. If this happens. If it does not happen, let's just say it does not happen, then it will just continue. Right. And I have to remember that I have to increase my window size, right? I have to increase my window size. So integer window size initially is equal to 0. So window size plus plus. In case we're not now, this is for example, we have 1, we add 1, we add 4. So we have 1, the value is not greater than 51. So we increase the window size and then we move on to the next index. We add 4, right? So we add 4, 1 plus 4 is so we add 4 to 1, which is 5. Still the value is not greater. We increase the window size. We have 45. The value is still 45. The value is 49. Becomes 49. It's still less than 51. We add 6. When we add 6, we have the window size as 4. When we add 6, we have the window size as 4 and the value as 50. And the value as 56, right? So this becomes 50 and this becomes 56, right? 5 and 45 is 50 and 656, and 56 is there. The value 6 is there and the 56 is there. This is greater than x. What we will do now is not, okay, I should say else, because this is less. Okay, we'll only increase the size if the current sum is not greater than x. If the current sum is greater than x, we're going to say window size minus minus. Okay, so we're going to decrement the size, and we just don't decrement the size. We're going to remove the value, right? We're going to say, now this is important. Okay, this is important. Try to understand this. This is important right here. So this is like this over here. Okay, so this is like this. Okay, what I want to do is, this is 0, 1, 2, 3, 4, and 5. The window size, which I'll call W right now. Okay, try to understand this very nicely. Okay, okay, we'll just make this like this and like this, right? Now the current window size, which is W, is equal to 4. Okay, 1, 2, 3, and 4. Current size is 4. The sum is equal to 56, which is greater than 51. So what we try to do is, we will try to remove the last index. How do we do that? We're going to subtract. Remember, we're going to subtract from the sum. We're going to subtract a of what? That is the question. We're going to subtract the value of I is there, probably as I is equal to 3. I'm going to subtract. I want to go k steps behind. I want to go till the last window, which means I can simply say whatever the window, so whatever the I value is, which is 3, for example, I'll subtract from it W minus of 1. Okay, reason being because this is 4, so it will become 3. So when it is 1, it will see that nothing happens. So 1, it will increment to 2, it will increment to 3. Okay, it will be actually 3. It will actually be 3. Okay, it will actually be 3. So one thing I need to make sure is I keep this as 1, because I want to return W in the end. And then I say, okay, W minus 1, which is 3. So 3 minus 3 is 0. So we'll remove, so we will remove this value. So we will say the value current sum minus, current sum is equal to current sum minus the value of array of window size. I should say I minus window size minus 1. Okay, so we remove this value, so we get 56 minus of 1, which is 55. Okay, and this is not an if, we will have a while, because we want to keep decrementing. We want to keep decreasing this value, this window size, till the point we have a value list, right? Because this could have been something, because this 6, because this, instead of this 6, we could have had a 7. If we had a 7 over here, then the value would have been 52 like this, in this size of 2 subarray, and we would have we would have updated the value, minimum value of window size to 2, right? But that didn't happen. Well, I'll show you that test case when we write the code. Okay, so this happens, right? And so current sum is current sum minus a of I minus window size minus 1. Window size is decremented. We'll keep doing that. So we do this, we have 55, then 55 is still greater than 51, right? 55 is still greater than 51. We'll say, okay, we'll have this, we'll decrement the size again, and we will have 45 plus 6. So we'll have 45 plus 6, which is simply 45 plus 6. Okay, but that is wrong, right? So, but I cannot do this. Okay, we cannot decrement if the size becomes less. So I have to say inside as well, if the value of current sum minus, of the value of current sum minus, or I think I should say while the value of, I should say while the value of current sum minus of a of I minus window size minus 1 is greater than x, then only we're going to do this. So for example, current sum is 56, minus 1 is greater than 55, is greater than 51, then only subtract this. Then we have 4. We'll say, okay, fifth, then we'll say 55, then we'll say 55 minus 4, which is 51, is greater than 50, is greater than 51, then only we're going to So 55 minus 4, which is 51 greater than 51, then only we're going to carry out this operation. Otherwise, we're going to increment the size again. Okay. Otherwise, we're not just going to increment the size, we're going to say window size plus plus, and the value, again, the value of window size is equal to minimum. This is the current window size. Okay, this is the window size. I'll just have a value integer answer. I'll just call it answer. Okay, I have this minimum size right here. Right, so I'll just say minimum size is equal to minimum of minimum size and window size. Okay, we can just return the return window size. I do think this should work. Let's see. A was not declared in the scope. Okay, sorry, this is A. Okay, right. So, right, I need to do this while we don't actually do that. Right, wait a minute. What if I just do this? Value comes out to be, oh my god, okay. The value is int max, I believe. Minimum of minimum size and window size. Okay, what is the problem? Integer is added dot size, minimum size is integer max. Current sum is 0 when size is window size is 1, integer size is 0. Current sum plus is equal to array plus is 1. So 1 is added, which means current sum is equal to 1. Current sum minus array of I minus window size minus 1. Okay, now I know because this probably did not execute very well. This probably did not execute very well. I minus window size was initially 1, and minus 1 actually made it like I is 0 already. And then you say minus 1, which makes it minus 1 minus 2. So array minus 2 actually does not exist. So I should say, but it could be a possibility that the it could be a possibility that the current sum is already, if the currents if, I mean there is a possibility that the element is itself, one of the elements is just greater, right? Right, so I need to handle the edge cases because I cannot actually calculate array I minus window size minus 1 initially. So to be able to do to be so to be able to do that, um I'll just say if I is greater than, if I do that, there's a possibility I might miss out on something. Okay, I'll just write something. If the value of current sum is greater than x, Just write it here. Okay, I'll just make this that I is good. The window size, I must be greater than the window size -1. This should work. So I get 4, the output is 3. Okay. 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 Let's I'll have to do a dry run over here. There's no other way to do this. I'll need to do a dry run. So 4:45. I'll just do a dry run, quick dry run. Just do a quick dry run, dry run. Right. Okay. 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 No, I want a pencil. Okay. So now what I was saying was, according to the code that I've written, we'll be going. Initially, we'll start with the current sum 0, window size of 1. Now what I want to do is initially calculate the current sum, which I'll call CS, which is going to be 1. Now, since this sum is not greater than, since the value of I is not greater than window size -1, which is 1 minus 1, okay, I is 0 and window size -1 is also 0. It's not greater. So we'll just move on. We'll say if the current sum is greater than k, that is also not true. So we'll increase the window size to, is initially 1 and we'll increment the window size to 2. Then so the window size is like this. So my red, this just basically, okay, I'll draw it like this only. Okay, it's just to have a real kind of, right. So the window size is like this right now. This current sum will become, so the window size like this. The current sum will actually become 5 now. The value of I is 2, I is 1. Window size is 2 minus 1, which is 1. Again, this is not true, right? Again, this is not true. So we'll move on again. We'll say the window size is, again, the value sum is not greater. So we'll say, okay, fine. We'll increment the window size to 3. We'll add 45 to this and we'll have 50 over here. Okay, 50 is here. 50. Now the value of I is 2. The window size is 3. Value of I is 2. Window size is 3 minus 1, 2. Wait, this way it will never exceed this. If the value of I is, okay, let's see what happens. Wait a minute. So, right, so the value of W is 3. I is equal to, I is 0, 1, another value of I is 2. So we add this. The window size is already 3. Okay, 1, 2, 3. And now we say, okay, the values, again, since, again, the value is still smaller, so we'll increment this to 4. We'll capture this. We'll increment this value to 3. We'll increment this to 56. The value of I is 3. Window is 4 minus 1. Again, this is not greater. It should be. But the value of current sum is greater. So that's why we say this. And okay, that's the reason. So I'm not able to. But if I write I, which is 3 minus, if I were to write 3 minus, okay, I'll just make this window minus size. I don't know. I thought that was 3 minus 3, 0. Right? I thought it would have worked. It should have worked out actually. Window minus window size. This should have worked. Okay, so this is actually okay. Still getting a 4. So the value of I is this time. Okay, yeah, it's still a problem because you're still calculating 3 minus 4. You must keep this as a 0. If you don't do that, then 3 minus 3 will not be 0. Right. Okay, it works. Perfect. All right. The value is 3 and 3. Let's give it a custom input now. So let's, for example, let's give it a custom input. If I had 7 over here, would it give me a value of 2 as it should? Does it give me a value? Do it again gives me value. See, this is a problem again. As I said, so it goes to 1, and then 4, and then 45, and then 7. Does it not just keep decreasing I minus window size minus? Okay. Okay. C, W, and the value of I. So we have one initially. Window sizes. We'll start with the window size of 0. Okay. I want to start with the window size of 1, which is actually the thing. Current sum is 1. Window size is 1 initially. We see this. We add this value. So I is 0. The current sum becomes 1, which is less than 51. So we add window size becomes 2. The value of I is 1. This becomes 5. Value of I is 1. This becomes 5. I is 1. This becomes 5. Still the value is less than 51. So this becomes 3. Value of I is 2. We add 45. This becomes 50. Value is still less than 51. We increment this. We add this. The value is I is 3. We have 52. And then we increment this size to 5. Okay, wait. Now we are not going to increment this yet. The value is 52. The value is 52. The value of I is equal to what is the value of I? So what is the value of I? Value of I is 4. Value of I is 3. Value of window is 4. Window size is 4. So I want to ask you, if this is 0, this is 1, this is 2, this is 3. I'm at this position. I want to subtract this position. How do I subtract this position? This is I. This is 1, 2, 3, right? So this is just basically 3 minus 3, 0. The window size is, if the window size is 3, it becomes 3 minus 3, 0. The window size is 4. 1, 2, 3. The window size is 4. Okay, agreed. The window size is, right. So if the window size, if I keep the window size as, if I keep the window size, whose side it should be greater? Just say if it is equal, keep this as 1. Window size minus 1. I say 4 minus 1, 3 minus 4 minus 1, which is actually 0. So I have 0. Window size becomes, okay, I'll do that. Listen to me. Just so 52 is the value. We'll adjust that. So we'll adjust that. And I'll say the current value, which is 52. Now I'll subtract. What am I doing? I'm going to subtract. What I'm going to subtract is actually from 52. I'm going to subtract array of I minus window size, which is 4, which is 3 minus 4. Window size minus 1. It should be plus 1. That's what I'm doing wrong. It should be actually plus 1. This is what I was doing wrong. This should be actually plus 1 because it is W minus 1. I'm subtracting from that. I'm actually subtracting from that. So it is W minus 1 actually. Such a small mistake and such a huge burden. So this is actually A of I minus W plus 1. Okay. So that will give me, actually that will give me, so 52, we check 52 minus A of I, which is 4 minus, so this is 3 minus 4 plus 1, which is 4 minus 1, 4, which is 0. So 52 minus we have 0. 52 minus a of 0, which actually gives me, which is 51. 52. I'm sorry, 50 plus 7. I'm sorry, 52. 50 plus, sorry, this is 50. I'm sorry, this is 57, right? So not 52, but 57. So 57 minus this is 56. I say, okay. Then I say the value of window size becomes, I subtract the window size and it becomes 3. I say I will take this value now. Now that I have the value 4. This becomes 56. The value of I remains the same. And I say, okay, this time it is 56 minus a of window size is, so the value of I is remains 3. The window size is 3 plus 1. So a of 1, which is 56 minus 4, which is 52, it is still greater. And this will work absolutely fine this time. Window size plus 1. It was supposed to be, if it is greater than window size minus 1, it is greater than window size minus 1 because I want to have, and then I'm saying I have window size plus 1, I have window size. So, oh my fucking God. Probably a test case I missed. What is this input?